Hi there, Mr. Carbis. Hope you're all doing well. Nice to speak to you all again. Yes, as you can see, we're going to be looking at earthquakes. So somebody was really interested in looking at earthquakes, so I thought we would delve into that. And it's really interesting because it ties into our volcano work. So if you remember when we looked at volcanoes, we looked at how our Earth, how our globe is split up into different layers. So I said that there was like three main layers. There's the crust that we happen to live on. There's this liquid mantle that's got all the magma, which is where the lava from volcanoes comes from. And then we've got the core. And the Earth's crust is split up into these giant plates that float on the magma, and they actually move. So the red lines show these boundaries where the plates meet. The edges of the plates, they're called faults, and as these giant, you could almost think of it as like a jigsaw. These plates move. They can rub together. They can push towards each other, or they could pull apart. And it's near these edges where we get mountains being formed, where we get volcanoes being formed, and volcanic eruptions, and where we get earthquakes. And it's really interesting. If you have a look where the UK is, where my little arrow is, you can say that we're actually away from the boundary, which explains why we don't tend to get strong earthquakes and why we don't have any active volcanoes, because we're away from all the excitement, the geological excitement. Okay, so how do these plates move? You can do this experiment yourself. Use two crackers or biscuits and have like shaving foam or custard or any sort of substance like that, and have the biscuits sitting on top, and you can experiment with how the plates move. So the shaving foam would be your magma, and the biscuits would be your two plates that you're playing with. So the rubbing together, when it rubs together, you have to think it's massive jagged rocks are scrunching past each other, and it builds up a lot of energy, and it's like trying to open a stuck door. You can't do it, and then suddenly the door flies open. Well, that's the same with the plates. They get stuck, they're trying to push past each other, but they're stuck, and then they release a lot of energy, and that's where earthquakes come from, all that released energy. Next, we're pushing them together, and you might be able to guess what happens here if you think what happens when you push maybe like Play-Doh together, two lumps of Play-Doh. Where it meets, it gets pushed up and up and up, and that's what creates mountains. In fact, this is still happening with Mount Everest. So Mount Everest is actually growing ever so slightly because it sits between two plates that are getting pushed up and forming these mountains. And the final main movement, is they could move away from each other. And if you remember, as they move away from each other, this creates gaps which the magma can bubble up and create those volcanoes and that volcanic eruptions. So I found this really cool website, which I'm just going to. So this is a map of the world. This shows all the plate boundaries, and if you click here, you can see the plate names should pop up. There they are. So there's 7 plates in total. Let me just double check. 1, 2, 3, 4, 5, 6, 7. Yeah, there are 7 plates in total, and all these are slowly moving. So our world is slowly changing slate, but this is slower than it takes your fingernails to grow. So you're talking like 1 centimeter over a year, which is very small. You can get a ruler and see just how small a ruler is. So there's the UK, and you can see we're on the Eurasian plate, or the European plate, if you like it. Europe and Asia is mixing those two countries together, and we're away from the action. But one of my favourite countries, Iceland, one of the few countries I've been to, sits in between these two plates. And if you click on these arrows here, now I've been to Iceland and I know there's lots of volcanoes. So which tectonic plate interactions, which movement are these two plates going through? I'm going to say, if you remember, we get volcanoes through the spreading and moving away from each other. And there we go. It shows a little picture of what happens when the plates pull apart. The magma has a chance to escape, and it forms these volcanoes. And then if you're interested in this country and how these movements formed this country, it's got a little explanation and some stats. So event, volcanic island formation, date. So it began to form about 55 million years ago. So older Mr. Carbis, even older than Mr. Carbis' mother, if you could believe that. Quite a way away. Place Iceland, and it tells you that the motion, it's the two plates moving away from each other. So feel free to, I put links up, feel free to use this to explore the different types of movements, see if you can find an example of each. So if we go over to San Francisco, I know that San Francisco faults, famous for their earthquakes. So that's those two plates that are grinding together, which would be slip. And it shows that that's what causes a volcano, as these two land masses move away from each other. All that pent-up energy like radiates out like a wave. Think of you throwing a stone into a pond. Okay, so this video is going to help you with Mondays and Tuesdays work. So let's show you Mondays. So on Monday, what I'd like you to do is identify bronze. I'd like you to identify where the UK is. So I'm going to put links up for using a world map to help you. So identify where the UK is. Where is it in relation to the plate boundaries? How close it is to plate boundaries? What does that mean? Are we likely to get active volcanoes? Are we likely to get earthquakes from where the UK is sitting? Silver, I want you to try and find where Iceland, Switzerland, and Japan. So that's three countries: Iceland, Switzerland, and Japan. Can you find them on the world map? Can you spot them? Where are they in relation to plate boundaries? So are they right on top of a plate boundary? Are they really far away? What does that mean? So if Japan's sitting on top of a plate boundary, does that mean they're likely to have mountains, or likely to have earthquakes, or likely to have volcanoes, depending on which motion they're going through? And then finally, gold, what I'd like you to do is to do your best to recreate this map that you can see. And I know that you're great at this sort of activity from when we did recreate the Earth. Some people did Earth Crumble, which I thought was amazing. So try and recreate this map. You could do a cake potentially. You could do a large run outside. So I was thinking maybe if you had any like blue fabric or blue chalk, which could be the sea, and then you could find like sticks or stones, which you could lay out to be the countries, and maybe find some sticks, some string, sorry, to be the plate boundaries. So I would like you to try and recreate this map, the tectonics map, and then name the 7 plates. So this here will help you, the 7 plates. On Hub, tectonic plate activity sheet, this will hopefully help you. So it's a map of the tectonic plates, and if you can try and think of which one is which, and then further down there is the answers. Now Mr. Cabis was going to set this as a learning task, but then I realised not everyone is going to have printers, so we're going to do things slightly differently. If you do have a printer, feel free to do this activity. It's quite a neat little activity. So here, tectonic plates are like big rafts that float on what? So what do they float on? So think of tectonic plates there on the crust. What is the crust floating on? And then you'll find the answers this side. So if you want to do that activity, feel free. The only reason I didn't set it was I realised not everyone was going to have a printer. Okay, so that's Monday's activities. And then what I wanted you to do for Tuesday it's try to recreate the 3 main types of movement. So that's that movement that we discussed, the slip movement, the collision movement, and the moving away. So the collide, the slip movement, and the moving away, the spreading movement. Can you try and recreate that using the shaving foam and biscuits that I suggested? And then I'll upload a video that gives a video demonstration of that. It might be easier to use Play-Doh for the collision to show how the mountains collide. And if you're trying to do the volcano, get the magma bubbling up, what you've got to realise is that these plates weigh an awful lot. So when you're doing the spreading motion, if you push down on the biscuits as well as away, push down and away, you should see that the magma or the shaving foam bubbles up, creating that volcanic eruption that you're looking for. Silver, that's when you use this activity that I showed you to explore which areas have different types of movement. So can you find one example of each and what happens in this area? So that's this one. Can you find an example of plates moving away and what happens? Can you find an example of plates colliding and what happens? So explore this activity. And then finally, for gold, there's actually one other type of plate movement that I didn't really mention. Can you find out what that is and what happens when this occurs? So there's 3 main types, but there's also another type that can happen as well. And it's sort of linked to this collision movement. So what is this other type of tectonic movement? What happens when this movement occurs? And you can find out by going through this map, and one of these areas, one of these plate boundaries will have a 4th type of movement. So hopefully that explains Monday's and Tuesday's activities for you. So Monday, it's getting used to where the UK is, where different countries are, and recreating the map. And then Tuesday, we're looking at the different plates, how they move. And we've looked at, we get volcanoes from plates moving away from each other, volcanic eruptions. We get mountains when we have plates colliding. Plates collide and they crumple up and push up into mountains. And we get earthquakes when plates try and slip past each other and they sort of get locked and then they jolt apart and it creates this wave. That is an earthquake. So I hope you find this useful. Keep it coming with your ideas. I am looking, and I think of these for lessons, because I find it's more interesting to learn about stuff that you're interested in. So, all the best, and yeah, take care, guys.